Hello students, after having gone through all the 4 exercises of the chapter Permutations and Combinations, so we are here at the last section, which is miscellaneous exercises. So there are about 11 problems given in the textbook, so let us solve all of them. So moving on with the first one, how many words with or without meaning, each of 2 vowels and 3 consonants, can be formed from the letters of the word daughter? So you have the word daughter, D-A-U-G-H-T-E-R. Let us try to identify how many vowels are there. So vowels, so you have A, E and U, whereas consonants are the remaining alphabets, which is D, G, H, T and R. So there are 3 vowels and there are 5 consonants. So given in the problem, we need to find out the number of words which can be formed from 2 vowels and 3 consonants, right? So out of 3, I have to select 2, and here out of 5, I got to select 3, right? So it's going to be 3C2 into 5C3. So this gives us 3 factorial divided by 3 minus 2 is 1 factorial into 2 factorial into 5 factorial divided by 5 minus 3 is 2 factorial into 3 factorial. So which is 3 into 2 factorial divided by 2 factorial into 5 into 4 into 3 factorial divided by 2 factorial is 2 into 3 factorial. So 5 into 2 is 10, 10 into 3 is 30. Now these 5 alphabets which have been chosen can themselves be permuted. In how many ways? They can be permuted in factorial 5 ways. Right? So you have 5 alphabets, they can be permuted in factorial 5 ways, right? So 5, 4, 3, 2, 1 gives me factorial 5 ways. So this indicates the selection. So the total number of ways would be 30 into factorial 5 ways. So factorial 5 is 120. So 30 into 120, which is equal to 3600 ways. Right? A very interesting problem. Question 2. How many words with or without meaning can be formed using all the letters of the word equation at a time so that the vowels and consonants occur together? So you have the word equation, E-Q-U-A-T-I-O-N. Now from this word equation, let us try to identify the vowels and the consonants. So vowels, so you have A, E, I, O, U. So all the 5 vowels are there. And consonants, you have the remaining of them. So you have Q, and then you have T, and then you have N. So there are 3 consonants, right? So from the word equation, you have 5 vowels and 3 consonants. So 5 vowels have to be together and the 3 consonants also have to be together. So they are together means they can be permuted in factorial 5 ways, and these consonants, the 3 consonants are together, so they also can be permuted in factorial 3 ways. So this is 120, factorial 5 is 120, factorial 3 is 6. So now what are the possibilities? I have one section of 5 vowels and one section of 3 consonants, or I'll have a section of 3 consonants or 5 vowels. So there are 2 ways here. So therefore it's going to be 2 into, so these are 5 vowels and 3 consonants. So it's going to be 2 into 120 into 6. So finally we get the answer as 1440 ways. A committee of 7 has to be formed from 9 boys and 4 girls. So out of 9 boys and 4 girls, a committee of 7 has to be formed. In how many ways can this be done when the committee consists of exactly 3 girls? So the first one is you have 3 girls. Right? So if there are 3 girls, number of boys and number of girls. So if I exactly choose 3 girls, then the remaining 4 have to be boys, isn't it? So I have to select 4 boys from 9. So it's going to be 9C4. And I have to select 3 girls from 4. So it's going to be 4C3. So it's going to be 9C4 into 4C3. So this is factorial 9 into factorial 9 minus 4 is 5 into factorial 4 into factorial 4 divided by factorial 1 into factorial 3. So when this gets simplified, we get the answer as 504. So I hope you can do the simplification. The second one, at least 3 girls. Now at least 3 girls means you need to have a minimum of 3, or you can have more than 3 girls. So what is the condition? So here, let me write the condition here. So you have number of boys and girls. So this is for the second one. So at least 3 girls. So it means if there are 3 girls, then I have 4 boys. But I can have more than 3. So if you have 4 girls, then you would have 3 boys. So both the possibilities are accepted. So for the first case, that is 4 boys and 3 girls, we already have the answer is 504. For the second case, 3 boys and 4 girls. So this is going to be out of 9 boys, we have to select 3. So 9C3 into 4C4. So this is going to be factorial 9 divided by factorial 6 into factorial 3 into factorial 4 divided by factorial 0 into factorial 4. Right? So if you calculate, you get the answer as 84. So now you have to combine both of them because both of them are accepted. So for 4 boys and 3 girls, you have 504 ways, plus 3 boys and 4 girls, you have 84. So 504 plus 84 gives the answer as 588 ways. So third one, at most 3. So at most 3 girls. Now what does this mean? I can have no girls in the committee. I can have 1, 2 or a maximum of 3. So now let us see what happens. So you have boys, girls. Now what is the selection process? So if there are no girls, I have 7 boys. If there is 1 girl, I have 6 boys. If there are 2 girls, I have 5 boys. If there are 3 girls, I have 4 boys. So all these 4 possibilities are accepted. Now for this combination, so total number of boys is 9 and total number of girls is 4. So that's given here. So here it's going to be 9C7 into 4C0. Here it's going to be 9C6 into 4C1. Here it's going to be 9C5 into 4C2. 9C4 into 4C3. So 9C4 into 4C3 has already been calculated, which is 504. So let's see what the others are. So of course this is going to be factorial 9 divided by factorial 7 into factorial 2 into. So use the formula for combination and calculate. So for the first case, you get the answer as 36. For the second one, you get the answer as 336. So I leave the calculations for you to do. And for the third case, it is 756. Right? So you have to add them all up. So when you add all of them, you get 1632 ways. If the different permutations of all the letters of the word examination are listed in the dictionary, so I have the word examination. Now they are all listed in the dictionary. How many words are there in the list before the first word starting with E? Now you have the word examination. So I would like to know how many words are there before E in the dictionary, which includes the alphabets of the word examination. Now if I observe this word examination, before E you only have the letter A. So you do not have B, C and D. All these 3 letters are not there in the word examination. So you only have the letter A, right? So therefore observe that here in this case, in this word there are 2 A's, and then if you observe there are 2 I and there are 2 N, right? So how many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So among these 11, I have to consider all the alphabets which are before E. So therefore So these two A's are considered as 1, right? Because before E you have A itself. So whether you have 2 A's or 1 A, it remains the same. So therefore, in total you have 11, but we consider 10 because these two A's are considered as 1. So 10 factorial divided by, so if there are any alphabets repeating, we have to divide it by the total number of repetitions taking place. So I occurs twice, so it's going to be 2 factorial. N occurs twice, so it's going to be 2 factorial. So it is 10 factorial divided by 2 factorial into 2 factorial. So that is 907,200 ways. Question 5. How many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7 and 9, which are divisible by 10? So they all have to be divisible by 10 and no digit is repeated, right? So I need to find the total number of 6-digit numbers, and this 6-digit number has to be divisible by 10. So a number is divisible by 10 if and only if I have a 0 here in its units place. So this is the units place, I need to have a 0 here. So there is only one possibility. So I choose 0 here, and then you have remaining 5 numbers. So you have 5, 4 ways, 3, 2 and 1, right? So therefore this becomes 5 factorial, which is 120 numbers. So question 6. The English alphabet has 5 vowels and 21 consonants. So you have 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So out of 5 vowels, I have to select how many? I have to select 2. And out of 21, I need to select 2. So it's going to be 5C2 into 21C2, right? So definitely we are selecting 4 alphabets. So this is going to be factorial 5 divided by factorial 3 into 2 into factorial 21 divided by 21 minus 2 is 19 factorial into 2 factorial. So this is 5 into 4 into 3 factorial divided by 3 factorial into 2 into 21 into 20 into 19 factorial divided by 19 factorial into 2. So 19 factorial and 3 factorial gets cancelled. So 10s are 2 2s are. So 5 into 2 is 10. This is 210. So it is 2100, right? So now you have the selection is 2100 ways, and these 4 alphabets. Now these 4 alphabets can be permuted in how many ways? They can by themselves be permuted in factorial 4 ways, that is 4p4. So it's going to be 4 factorial. So 4 factorial is 4 into 3 into 2 into 1 into 2100. So this is going to be 24 into 2100. So you get the answer as 50400 ways. Question 7 is an interesting one. In an examination, a question paper has 12 questions. So there are 12 questions and you have part 1 and then you have part 2, right? So part 1 has 5 questions, you have 5, and part 2 has 7 questions. A student is required to attempt 8 questions. So he has to answer how many questions? 8. So 8 questions have to be answered. But what is the condition? He has to select at least 3 from each part. So let us see what happens. So if a student selects 3 questions from part 1, then he has to select the remaining 5 from part 2. If he selects 4 questions here, he has to select 4 from part 2. And if he select all the 5 questions from part 1, he has to select 3 from part 2. So this is it, because you have to at least select 3 from each part, right? So I cannot go below 3 either in part 1 or part 2. So for the first case, this is going to be 5C3 into 7C5. And then you have 5C4 into 7C4. And then you have 5C5 into 7C3. So find the values. So if you calculate, the values are 210, and this is 175, and this is 35. Now you add up all of them, so you get 420 ways. A very interesting problem. Problem 8. Determine the number of 5 card combinations out of a deck of 52 cards if each of the 5 card has exactly 1 king. Right? So we know that you have to select a 5 card combination, and among these 5 you need to have 1 king. So there are 4 kings, and then you have the remaining 48. So I have to select one from this combination. Among these 4 I have to select one, so it's going to be 4C1, and among the remaining 48 I have to select 4, so it's going to be 48C4. So very similar to our problem what we had done in exercise 7.4. So you get the same answer in 5. So it's going to be 4C1 into 48C4. So you get the answer as 778,320 ways. Question 9. It is required to seat 5 men and 4 women in a row so that the women occupy the even places. How many arrangements are possible? Right, so totally there are 9. So let me list out the places. So this is place 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so the women have to occupy the even numbered places. Right, so there are 4 of them. So here among these 4 I have 4 ways, and here I have 3, then you have 2, and then you have 1. Right, among these 4 in position 2 in the even place I have 4 ways of placing these 4 of them, 3 ways in placing the remaining 2 and 1. So among the 5 men here I have 5 ways, 4, 3, 2 and 1. So among these 4 women who have to occupy the even numbered places, for position 2 I have 4 ways, position 4 I have 3, position 6 I have 2, and position 8 I have 1. And the 5 men, for position 1 you have 5, for 3 you have 4, for position 5 you have 3 ways, for position 7 you have 2 ways, and position 9 you have 1 way. So you have to multiply all of them. So this is nothing but 5 factorial, all the odd numbered places. 5 factorial into 4 factorial for the even numbered places. So it's going to be 120 into 24, which is 2880 ways. Question 10. From a class of 25 students, 10 of them are chosen for an excursion party. There are 3 students who decide that either all of them will join or none of them will join. In how many ways can the excursion party be chosen? Right? So out of 25, I need to choose 10 of them, and 3 students are such that either they will all come or either they will not come. Right? So let's assume that if all 3 of them come, right? So all 3 go to the excursion party. Among 25, 3 of them have already been chosen, so I have 22. So out of 22, I have to select 7. Right? So if all these 3 decide that they do not go for the excursion party, then among the remaining 22, I have to select 10. Right? So it's going to be 22C10 plus 22C7. So this is the answer. Right? In how many ways can the letters of the word assassination be arranged so that all the S, the letters S are together? So I find that there are 4 S. And how many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 of them. Right? So 13 minus 4 is 9, plus all these 4 S together, which is 1. So totally you will have 10 of them if all the 4 S are together. Right? And apart from that, I have A's. How many A's you have? 1, 2, 3. So I have 3 A's. And then I have 2 I's. And also you have 2 N. right? So what are the total number of possibilities? It's going to be 10 factorial divided by 3 factorial into 2 factorial into 2 factorial. So that gives an answer 151200 ways. A very easy problem. So this completes solving all the problems given in the miscellaneous exercise after exercise 7.4. So do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and thanks for watching.